Another interesting question we have here. If you studied physics or you love physics, then this video is for you and you want to watch it to the end. This question is under frictional force, and this question gave rise to this figure. If you want to understand how this works, or you want to see how we're going to solve this problem, then sit back and watch this video. Let us start from the scratch. Let me take out this figure so that we can start from the scratch. The question says a 4 kg box is placed on a 30 degrees inclined plane. This is what it is. This red line is the inclined plane that is placed at an angle of 30 degrees to the normal horizontal surface. And then the 4 kilogram box is placed on the inclined plane. That is what the first sentence represents. The coefficient of friction between the box and the surface is 0.2, an information to take note of. Calculate the acceleration of the bus down the slope. We are to take the acceleration due to gravity g to be 10 meters per second squared. This box moves down the slope. So we are looking for the acceleration with which the bus moves along the slope. For this bus to move down the slope, it means a force that is parallel to the slope must be acting on that box. Let us call that force F. Again, we are told that friction exists. And friction, like we know, opposes motion. So if this force wants to move this object down the slope, friction will oppose it in the opposite direction. So let's call the opposing force the frictional force, Fr. Now we have this setup. What we need to know is that this object moves down the slope. For this object to move down the slope, the force that actually moves it down the slope must be the difference between this parallel force and this frictional force, because if both of them are equal, this object will not move. For this object to move down, it means F must be greater than what? Fr. So the difference between F and Fr, which we call the net force, is the force that actually pulls this object down the slope. What it means is that in this video, we need to find the value of F, or find a formula that represents F, and also a formula that represents the frictional force, Fr. Let's not forget that this object has a weight, and for every object, the weight acts vertically downward. So the weight of this object, W, acts vertically downward because acceleration due to gravity acts downward. The formula for weight is mass times acceleration due to gravity. So we have the weight of this object giving us mg. Now, let's start by looking for the frictional force, Fr. What is the formula for frictional force? Frictional force is giving us mu r, where mu, this symbol here, represents the coefficient of friction for which we are giving its value as 0.2 in this question. Then, what is r? R is the normal reaction. The word normal reaction, normal, means 90 degrees. It is the weight of the object that is always perpendicular, that is always normal to the surface, that is always perpendicular to the surface bearing the object. If you look at this weight, it is not perpendicular to this surface. The reaction R must be perpendicular to this surface. Hence, this is the reaction. This is where we are going to have it. R, because this is now perpendicular at 90 degrees to the surface. This is where R is actually acting. This is the normal reaction of this object. So now we have the R here. We need to know the value so we can forge ahead by solving for the frictional force. Even if we don't know the value, let us write a formula for R. Looking at this figure, you would have seen that this inclined surface was rotated through 30 degrees. Definitely, this R must have been rotated through 30 degrees as well. If this angle is 30 degrees, then if we form a small right angle triangle here, we can be able to find the value of r, or at least we can be able to find the component of the weight that represents r. So let's close this up and have a little right angle triangle here. From here, we can find r, because r becomes the adjacent side of the triangle, while w is the hypotenuse. There is a relationship between the adjacent and the hypotenuse, and that relationship is cos, which means that r will be equal to w cos 30 degrees. So r equals w cos 30 degrees. I have just replaced the w with the formula mg. So our r will be equal to mg cos 30 degrees. Now that we know r, or the formula, let us put it back into the formula for frictional force. So frictional force will now be equal to mu times mg cos 30 degrees. Now, let's come back to this force, F. F is parallel to the surface, the inclined surface. If you note, this side of the triangle is also parallel to the inclined surface. So if we can find this side of the triangle, we have equally found F. So let us represent this side of the triangle with the force F. Now, F becomes the opposite side, while W still remains the hypotenuse. What is the relationship between opposite and hypotenuse? It is sine. It means F is W sine 30 degrees. F equals W sine 30 degrees. Again, I've replaced the W with the formula mg. Now we know Fr and we know the parallel force. What is now the net force? That net force, remember I said there is a net force pulling it along the ground, which is the difference between F and Fr. F must be greater than Fr for this object to be pulled down the slope. So let us find that net force. F net, which is the net force, will be the difference between the parallel force and the frictional force. What we just need to do is to put the formulas. F is this, frictional force is this rather. So let's put it here. It means F net is equal to mg sine 30 degrees minus mu dot mg cos 30 degrees. We can solve from here. If you look at the right hand side, mg is common to both sides. Let's factorize it out. F net will be equal to mg into sine 30 minus mu cos 30. This is the net force that is pulling the object along the slope. Remember, let's move to the next page. Remember that the net force, or the formula for force, is generally given as mass times acceleration. So if we replace the net force with the formula ma for mass times acceleration equal to this, then we can be able to find the acceleration that is pulling the bus down the slope. To obtain A, we divide both sides by the mass m. So the m cancels this and it also cancels this. And what we are left with is A equals g into sine 30 degrees minus mu cos 30 degrees. This is the formula we have been looking for. And this is the formula we are going to use to calculate A. Before we proceed, let us look at the implication of this formula. Looking at this formula, you will not find mass anymore. What it means is that the mass or the acceleration does not depend on the mass of the object. If this is 20, 100, 1000, 50, it does not matter, because whatever the mass is, the acceleration will remain the same under this setup. So the acceleration for an inclined plane does not depend on the mass of the object. Now let's continue by putting in values. A will be equal to 10 for the acceleration due to gravity as given in the question. Sine 30 degrees is 0.5 minus mu was given as 0.2 times 0.866, the value of cos 30. 0.2 times 0.866 gives us 0.17. The difference between 0.5 and 0.17 is 0.33. So we have the acceleration to be equal to 10 times 0.3, and that gives us 3.3 meters per second square. So this is the acceleration that the boss used to move down the slope. Very simple, very interesting. I believe you enjoyed it. If you did, I have a simple one for you. This is another simple question under friction. Read through the question, solve it, and put your answer in the comment section, and I'll be there waiting for you. Once again, I want to thank you for watching this very interesting video. If you like it, please give it a thumbs up. Drop your comments, and most importantly, share it to your learning colleagues. That way, you keep encouraging us to make interesting content. The link to my YouTube channel is in the video description and in the comment section. Kindly subscribe to my YouTube channel. Thank you for watching and hope to see you in our next video.